Experimental study of behavior of castellated beam with diamond shape opening under lateral torsional buckling. Abstract, this project discusses optimization of the depth of opening, i.e. depth of opening of castellated steel beam containing diamond openings. Optimization of opening of diamond shape was performed using finite element method, FEM. The results of FEM analysis are verified by implementing laboratory testing of 150 mm height castellated beam specimen. All the castellated beam specimens were modified from 100 mm I-beam. Optimum results from FEM analysis was a castellated beam with diamond openings having opening size overall depth with D/D0 ratio 1.25 and D/D0 1.75. From laboratory testing results and FEM analysis it is observed that, the deflection obtained from FEM result is 0.900 mm, while deflection from experiment results is 0.933 mm. Percentage variation in above case is almost negligible, that is 3.66%. Keywords, optimization, castellated beam, diamond openings, finite element analysis. Introduction. This project work is mainly focused on parametric study of perforated web beams. The main aim of work is to optimize the sizes of openings provided in the beam. In this chapter some introductory information about perforated web beams are summarized. History of perforated web beam. Castellated name come from the Latin word whose meaning is to structurally fortify. Before castellated beams, I-beams were used in construction because they are a strong and solid way of supporting houses and other industrial structures. Castellated beams were developed as structural channels to increase the beam's depth of parent I-beam and strength without adding additional material causing no change in weight. Since the 1950s, because of shortage of steel and increase in cost of steel, castellated beams get started to be used in the construction. Castellated beams were advanced in Europe to overcome the steel shortages and high cost of steel. Castellated beams are the beams having different geometrical shape perforations in the web of beam. The different shapes such as hexagonal, circular, rectangular, diamond, sinusoidal etc. are used in castellated beams. These shapes are constructed with the help of computer-controlled cutting torch to cut the section according to given geometry. Types of castellated beam. Depending upon opening there are different types of castellated beams. Following are the different types of castellated beams. Circular opening, sinusoidal opening, diamond opening. Figure, castellated beam with diamond opening. Literature review. The study on castellated beam based on various size and shape of opening, varying center to center distance between two openings was studied in various literatures. In addition to that the behavior of castellated beam for flexural was also studied. But the very little study on effect of lateral torsion on castellated beam. Objective. 1. To study buckling behavior of castellated beam under lateral torsion using Abacus software. 2. To validate Abacus software results experimentally. 3. To investigate effect of torsion on diamond-shaped castellated beam by taking various depth of opening to depth of beam ratio. 4. To optimize position of depth of opening to depth of beam ratio and suggest guideline for the ratio. Parametric study. In this chapter, parametric study is explained. Also, the details of terminologies of castellated beam and the guidelines given by Eurocode for perforation are given. The parametric study of castellated beam for various combinations such as size of opening, i.e. depth of opening and length of opening, are presented in this chapter. Figure, typical castellated beam with its cross-section. Terminology in castellated beam. Before going to analysis of castellated beam it is important to understand few basic terminologies used in the geometry of castellated beam. These terms are illustrated in the following figure 3.1 where do equals depth of opening provided. D equals overall depth of the opening. S equals center to center spacing between the two opening. E equals clear distance between two opening. B equals width of flange of I-beam. TF equals thickness of flange of I-beam. TW equals thickness of web of I-beam. Detailed methodology adopted. The procedure used in the project was divided into 3 steps. First step is related with software analysis in computer. Method used for analysis of castellated beam with diamond opening was finite element method. Deflection was computed from software analysis which is then verified by performing the second step which is laboratory tested of castellated beam. In third step after comparing the result parametric study was conducted for optimization of ratio. Method of analysis. Abacus 6.14 CAE was used to analyze the castellated beam with diamond opening. The finite element model is linear for deformation and material behavior. Material properties for steel are modulus of elasticity E equals 200 GPa and Poisson's ratio equal to 0.3. The beam examined in the study are simply supported at the end and loaded with 2-point loads at length by 3 distances. Table, parameters considered for diamond-shaped opening. Fabrication of castellated beam. Case-Delated beam has been derived from the I-beam having depth 100 mm. The diamond pattern has been created by using machine i.e. profile cutter. For that first the detailed drawing has been made. In case of profile cutting, cutting profile has to draw on software with the real scale. Cut profile for cutting diamond opening. Modeling and analysis. In this chapter, finite element analysis of case-delated beam having diamond opening in Abacu software is explained. Important points in FIA are discussed and steps for modeling are described in brief. From software result it is found that for D/D0 ratio the value of stress is 235 N/mm2. Further as D/D0 ratio increases, value of stress also increases. The beam whose depth has been optimized, same beam has been taken for optimization of width, i.e. D/D0 ratio equal to 1.45 for optimization. After analysis it is observed that D/D0 ratio equal to 1.5 and takes the stress of 223 N/mm2. Conclusions. 1. From the software results the buckling of case-delated beam for diamond opening is nonlinear. The shape is not uniform. 2. Percentage error. It is found that experimental results are differed by 3.85% with software results. This error is within acceptable limit.